Ramanujan for G is now available on the Google Play Store. Try it out for free.
We are going to continue the discussion, but before that, I'm going to do a little bit of bookkeeping for with respect to our lectures. So as of now, I want to explain to students how they can make the most use of our platform. Okay, so our platform, to access our platform, basically you have to go to, like, if you are a NEET student, go to Google Play Store and look for com.jnanamarga.sushruta. If you are a JE student, you must look for com.jnanamarga.ramanujan. So regardless of the platform, what you have to do is you should try to make the most use of everything. Our platform works like this. Okay, we make we overlay ebooks with slides, with videos, and with assessment. Okay, slides, videos, assessment, and search. You know, so now students who buy our tablet version will get the same app. But on top of it, they will get additional material. So if you are a NEET or JE student and you're in the 11th class, then you are in the right place. You should be watching these lectures. If you're in the 12th class, also you can watch these lectures as a refresher. Okay, and so what you do is you download the app and then you go about your business. Okay, you get 2 weeks free, and after that you have to pay. It is a very minimal charge. If you go to Akash, you go to Alan, you go to Baiju, they will charge you an arm and a leg, two lakhs, okay, or maybe more. Now, students who use our cell phone app, we recommend that you purchase for physics, because I teach physics. You purchase HC Verma Part 1 and Part 2. Otherwise, if you use our tablet version, HC Verma comes in electronic format. So you get a full platform, and then you will get Newton's first law of, and then you will get, the whole package. Okay. So we were discussing Newton's first law, right? The last class. And then we discussed inertial frames. We explained the idea of a free body diagram, and then we got to the place where we started discussing forces. Right now, there are various forces. The most important 4 or 5 forces are gravitation. In the case of mechanics, we are dealing now only with mechanics, not talking about electricity, magnetism, although we will touch upon it. But in mechanics, the most important forces: gravitational force, normal force, tension, okay, frictional force. Frictional force comes in 2 varieties, right? So these are the 4 or 5 very important forces, right? Now, what is the gravitational force? The gravitational force is the force between any 2 masses, but most often we talk, it happens between any 2 masses. But you shouldn't be confused by that statement. It's a force of attraction between all masses in the universe. You shouldn't be confused with that. Most often, when you solve problems which don't deal with big masses and bodies, right, in the context of like table, inclined plane, etc., you want to note that we are only talking about the gravitational force of the earth on a body. Every body is attracted by the earth, right? So that is gravitational force. The second set of forces, we have this electrostatic force right now, I don't want to confuse you, is the normal force, right? What is the normal force? The normal force is the force that, let's say I have this book, right? Earth is attracting this book, F equals ma, it should fall to the ground. It will. What is the acceleration that it falls to the ground? F equals ma. What is the A? G, 9.8 meters per second square. If you just let it go, it falls to the ground, 9.8 meters per second square, right? But if I hold it like this, there is another force which stops it from falling, right? What is that force? That is the normal force exerted by my hand on the book. By my hand on the book. So I have kept this laptop. This laptop is sitting on top of this table. So the table exerts another force on the laptop. There is already one force on the laptop, which is the Earth's attraction, gravitational attraction. The second force, the normal force exerted by the table on the laptop. Now, if I try to push the laptop, I'm not able to push it because there is another force called static friction. When there is no motion, we say that the object is static, right? And therefore we have static friction. Now, if there is motion, then also there is friction. I find it so hard to push it, right? That friction is called sliding friction. Okay? That friction, so the static friction is at most mu s, at most, note the word, at most, mu s times the normal force. It is at most. The dynamic friction is always a constant. Note this, right? Static friction, you keep pushing, less, not enough, right? It will repel whatever force you are applying. Remember, static friction happens in the horizontal direction. The force you apply is in the horizontal direction. This guy is pushing the horizontal direction, right? Gravity and normal force are in the vertical direction. This force is in the horizontal direction. The more he pushes, the more static force friction resists. It resists up to a point after which he manages to push it. When he starts pushing it, you go to what? Dynamic friction. And dynamic friction is a horizontal line. It's mu k times n, where n is the normal force. This is at most mu s times n, where mu is the coefficient of static friction. Coefficient of static friction represents the maximum. It is a maximum friction value. Mu s times n is the most. Okay, so notice these two. Friction was always in the opposite direction to the direction in which he is trying to push. Okay, so now we then discussed this idea of the free body diagram last time, and then you draw all these free body diagrams, and then you solve these free body diagrams, and then you make the answer. Okay, so if assumption is correct, the friction is static. That is, if it is that, so is the body moving or not moving? First question you ask: is the body moving or not moving? If it is not moving, it is static friction. If it is moving, it is dynamic friction. Okay. Now, if the assumption is correct, is static, then it is an unknown. The friction becomes the unknown. If it is moving, it's dynamic, then the friction is unknown. You see? So if it is not moving, the acceleration is zero. So the acceleration is known. When it is moving, the acceleration becomes an unknown, but the friction becomes a known. Okay, so that's the trade-off between the whether it's moving or not. So notice and understand these the tricky trade-offs in this. Sigma Fext equals ma, and you solve a vector equation. Sigma Fext equals ma is a vector equation. You solve it in this direction and in this direction. In the case of the inclined plane, you have two components. So then we came across this problem. A block of mass 10 kg is kept on a rough inclined plane as shown in the figure. A force of 3 newtons is applied on the block. The coefficient of static friction between the plane and the block is 0.6. What should be the minimum value of P? So there is a second force, right? Such that the block does not move downwards. Okay. So now, if you don't do anything, right, the block is going to, the force downwards is pulling it this way, and the static friction is this way, right? Now, but then what he's trying to imply is if you don't apply P, then it's going to slide. That's what he's saying, right? But then you're holding on to it so that it does not go. It's like one guy standing like that. He's standing, and he's making sure it doesn't fall. It doesn't move. Okay. So because he makes sure that it doesn't move, so the friction is in this direction, right? And it is exactly 0.6 times n, right? So what is n? So what are the forces in this direction? There is the component of gravity along the inclined plane. What is the normal force? It is equal to the component of gravity perpendicular to the inclined plane. So 10 times g is 100 sine 45 is n. 100 sine 45 is n. 1 by root 2, 100 times 1 by root 2. So it's about 70, somewhere there. So n is about 70. Now, there is a 3 down, and there is also another 70 down. So 73 downward, right? So how do you get the other 73 down? Is the component of the weight. So 73 is down, and in the upward direction, you have another 60. Where did the 60 come from? 0.6, not 60, 42, right? 0.6 times 70, right? 7 mu times n, us times n is the frictional force. So 73 down and 42, 0.6 times 707 for us, right? So somewhere there, right? 0.6 times 0.707, right? That will be the force in this section. Okay. So now 73 down, 0.6 times 707 up, right? So now 0.6 times 707, 73 minus 0.6 times 707 you will have to apply, so to keep P, it should be the minimum value of P. 73 minus 0.6 times 707, right? So 3 newtons plus mg sine 45 equals P plus 0.6 times mg cos 45. So if you do the arithmetic, you end up with 32 newtons, right? So you should know 73 minus 42, right? 73 minus 42 is roughly 32, right? So very straightforward, actually. So having solved this, let's move. Now we are going to introduce this other concept called a pseudo force. This is not last time I didn't introduce it. I did this example. This is just so far what we've done is just a refresher for what we did last time. I wanted you to learn that. Now, what is this pseudo force? This pseudo force, they will say, pseudo force, Coriolis force, D'Alembert force. Like that, they'll throw all these names at you, and then you will say, oh my God, this is very, very tricky, very, very tricky, very, very tricky, right? It's not that tricky. Normally, there is no such thing called a pseudo force. Okay? There are only inertial frames and there are non-inertial frames. Okay? Now, if you want to make Newton's laws apply from a non-inertial frame of reference. So when does that happen? Let's say you are in a lift. Okay, you are the observer. You are in a lift, and the lift is falling. Okay, so if you are in a lift and the lift is falling, then and you are observing, say, whatever you're holding in your hand, right? What happens? It seems to just be suspended animation, right? Because the lift is falling. Now, to you, in reality, it is also falling, right? So, let's say you had your hand like this on a book and the lift was in free fall. You're going to die soon, but guess what's going to happen, right? The book will appear as though it is staying in the same place, right? Why? Because the lift is falling, right? Now, of course, you should be scared, but not everybody is scared. The poet Bharati once said, right? When the sky is falling, like, from its peak, it is breaking and falling, even then you should not be scared. உச்சி மீது வானிடிந்து வீழுகின்ற போதிலும் அச்சமில்லை அச்சமில்லை அச்சமில்லை. That means even when it's falling, don't be scared. Okay, so now when you have a problem with the Coriolis force, right, D'Alembert's force, right, how do you deal with that? What you do is you apply a to every m times a to every element in the reference frame. Okay, so let's say you're falling downwards with G, you apply an m times G to every reference, to every object in the reference frame. So that is how you combat or deal with a non-inertial frame of reference. Okay, I will show you an example. Here is a van. Okay, there is a pendulum in a van, right? So now, and the van is accelerating in the horizontal direction with an acceleration of a naught. Now you are in this, if you are in the absolute frame of reference, you will solve it as an absolute frame of reference. What is happening to the pendulum? It has a horizontal acceleration of a naught, this way, right? But let's say you are sitting inside the van. Okay, pendulum is now like this. That's what will happen to the pendulum. It will be at an angle, right? And so now you want to solve the thing. You're saying it's at rest. It's now like this. It's at rest, right? So, but actually it is accelerating. It is accelerating and a naught, right? So, but if you want to evaluate it, you apply an ma naught force, pseudo force, to counter the accelerating reference frame. So you add a force m times a naught in the opposite direction. Once you add it, then you can solve it as a static problem. Okay, T at an angle, mg, ma, T, right? So if that angle is theta, right? This angle is theta, then this angle is theta, right? So T cos theta equals mg, T sin theta equals ma naught. And you solve for it. What will be the angle theta? It will be a naught over g. Tan of the angle theta will be a naught over g by, when you divide the two equations. The t's cancel, the m's cancel, therefore tan theta equals a naught over g. Okay, so so if you accelerate further and further and further, it will start going upper and upper and upper. Okay, that's what they are saying. Okay, so at the point where a naught is equal to g, tan theta will equal 1, tan 45 is equal to 1. It will be exactly 45 degrees. Okay, so if you're accelerating at g horizontal, very high acceleration. Okay, so here's another example. Okay, an object. So why are we doing these special problems? Because you'll see some of these problems when you in some of these IIT exams, maybe even a NEET exam. They want to see if you've learned a little bit more. Okay, they want to know. I want to see if this boy has got this, or this girl, she has understood. This girl has understood. All right, now she knows a little more than the other people, right? Now, so an object is kept on a smooth inclined plane of 1 in L. What is 1 in L? The elevation is 1 for an length of step. Okay, now the horizontal acceleration to be imparted to the inclined plane. So they want to put an acceleration a to the inclined plane, so the object remains stationary. Normally there is no, it's a smooth inclined plane. Smooth means there's no friction, right? So normally what will happen? Let's say the inclined plane was fixed, right? This body will slide down, right? Now what he's saying is, I'm going to accelerate it, and as a result, it's going to stay stationary. I'm going to accelerate it. Okay, so when you accelerate it, how do you deal with that? Okay, so if you're accelerating it this way in a non-uniform frame of reference, you put one MA this way. Notice the MA this way. You do one MA on every object. There are 10 objects. Every object you do an MA. If there is if this is M1, M2, M1A, M2A, M3A, like that, every object you add a pseudo force. And so now you're dealing with it in a, you have converted the non-inertial frame of reference into an inertial frame of reference by putting that alternative. Going this way, you put it that way. Okay, so now you have three forces on the inclined plane: the normal force, the mg, and the ma. So now mg cos theta equals n mg sin theta, mg cos theta plus ma sin theta equals n. Okay, mg cos theta plus ma sin theta equals n, right? And then mg sin theta equals ma cos theta. So if you take mg sin theta, ma cos theta, then you have a by g equals tan theta, and tan theta is what? Tan theta is 1 by L square, square root of L square minus 1. 1 by square root of L square minus 1, tan theta is from Pythagoras here. 1L, this is square root of L square minus 1, right? So tan theta equals A by G, right? And it is A is equal to G tan theta, and tan theta is 1 by L square. Okay, so 1 by square root of L square minus 1. So C, G by square root of L square minus 1. Okay, so very clear, very simple. If you understand what you're doing when you have to use deal with a non-inertial frame of reference. Okay. So today, let's look at the next set of ideas which deal with an object in a curved path. When an object moves in a curved path, it ends up with two kinds of acceleration. An object which is in uniform circular motion, that is moving at a constant velocity in a perfect circle, that such an object is said to be in uniform circular motion. Such an object which is moving at a constant velocity in a circle has only a radial acceleration. Radial means towards the center. Radius is a line that joins the point to the center, right? So like that, radial acceleration towards the center. Now, if it has also a tangential acceleration, then the tangential acceleration will cause it to go faster and faster and faster and faster. Okay, so object in a circle experiences a radial and a tangential acceleration. So now let me come back to this. In this figure, see what is happening is the body is falling, right? The inertial frame, the black ball moves in a straight line. Okay. However, the observer who is standing in a non-rotating frame of reference, he sees it like this. He sees the object as following a curved path. Okay. So what can you say? So he is moving, so he thinks it's moving in a circle, but actually it's falling in a straight line. Okay, that is what, to deal with those cases where the observer is moving, non-inertial frame of reference, that's when you use this pseudo force. Okay, this case, if you move it, the object is stationary and therefore you want to be also moving. Now, let's say the inclined plane is moving and you're also moving at the same A, then you will see the object as stationary. That's the point we are making. And that's how we introduce the pseudo force. So I'm done with the pseudo force. Now I'm talking to you about the two components of acceleration. One is the normal component or radial component, then there's the tangential component. Object in uniform circular motion has no tangential component. Object in with a force towards the radial acceleration has a v square by r, as you know, right? Therefore, you have A equals dv by dt times et plus v square by r en, generalized curved path, object in a curved path. Now, uniform circular motion, you have only a radial, and it is v square by r, right? And we derived it. If you see our lectures, you will notice how we derived this equation as well, v square by r, right? And you must see it will be there in any textbook. The Professor H.C. Verma definitely has how to derive this v square by r. Okay? Now, and so v equals, normally when you say what is v, it is omega cross r, where omega is the angular velocity, v is velocity vector is a vector, omega is angular velocity, also a vector, r is the position, also a vector, so v equals omega cross, right? Omega cross r, right? And so, and a equals is towards the center for uniform circular motion with an AC, centripetal force. So you end up with F net equals MA and A equals V square by R, or omega square R, let V equals omega cross R. Therefore, you have V square becomes omega square R square, right? And therefore, one R will cancel out, the other R will remain in the numerator, so M omega square R, right? So V equals omega cross R, right? And omega and R are perpendicular. Omega, if it was going like this, omega is towards you. Okay, so omega is, direction of omega is, if it is going like this, the direction of omega is like that. If it is going like this, the direction of omega is like this. Okay, so you must notice that. Okay, so now the angular velocity is 2 pi by t, right? If you're in uniform circular motion where t is the period, now the frequency is 1 by t, right? So omega equals 2 pi by t, and v equals, therefore 2 pi f, omega equals 2 pi f, v equals r omega, and omega equals and a equals omega square r, or v square by r. So notice all this. Alpha equals angular acceleration. In uniform circular motion, what is the angular acceleration? 0. Okay, so you must note all this and note it very well. Then you will be very good in solving any of these mechanics related problems. And also, not just this, when you deal with Lorentz force, you will have the same issues. And so learn your mechanics well, not just because it's applied here. They will take it and make problems for you in electrostatics, electricity, or in Lorentz force, magnetism, and therefore that's why you must learn everything very well in the basic. Force you must understand, work you must understand, energy you must understand very, very well. And therefore, then it will give you the basis on which to attempt to learn all your material. Okay, so tangential acceleration is alpha times r, alpha cross r. Okay, therefore notice all these terminology, tangential, radial, all that you must note very clearly. Okay, so alpha cross r is the tangential acceleration, right? And the total acceleration is the sum of the vector sum of the radial and the tangential acceleration. Okay, so every quantity in linear has a rotational equivalent. First thing you must know. Angular linear displacement, angular displacement, velocity, angular velocity, momentum, angular momentum, mass, moment of inertia, force, torque, acceleration, angular acceleration, rotation, precession. Precession is what happens to the top when it kind of that spins, right? That is precession. Precession happens when your angular momentum is changing in direction. Okay, and the torque is perpendicular. All right, so you will deal with that when you deal with the top, or there are other some of these other devices which you will meet when you look at angular when you look at circular motion, and you must learn all these in very great detail. Moment of inertia, is a tensor, but don't worry about that. You learn how to solve for integral r square dm, right? Then you learn all these details ideas that you learn in linear. They have equivalents and they apply very, very similarly, but you must know how to apply them and do a lot of problems dealing with both linear and then also angular. Don't go to angular first. Always be very good with the linear. Understand force, understand how linear motion happens, including circular motion. Then you go to angular understanding. Okay? Now, uh, stone thrown, etc., right? Projectile motion, that is linear motion. It is only rarely that you have to use angular velocity in its context. Right now, don't worry about that. A passenger of mass stands on an elevator of right. So now you try to understand what happens when the elevator starts accelerating, right? What all happens? So draw all the free body diagrams. Try to understand it first as you are viewing it from an inertial reference plane. You're a person sitting outside, and then you watch it drop with a certain acceleration. Now let's look at a couple of MCQs in dealing with linear, right? Dealing with kinematics. All the graphs below are intended to represent the same motion. One of them does it incorrectly. Okay, so this is really tricky. Really, I'll tell you. Okay, so now if you have a positive velocity, right, then positive velocity, positive velocity, positive velocity. So at this point, you have the highest position, right? Positive velocity, you keep going, 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 going. Stop. Then you start going back, 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 back. Okay. So what is your acceleration versus time? Acceleration versus time is 0 and negative. It is decelerating. Fastest at this point stops and then goes backwards, right? So its position will eventually go back to 0. So this and this are represent the same thing. Position versus time and velocity versus time, right? So now, what can you say about the velocity versus position, right? So the velocity, so it goes like this and then it retreats, right? So you can see that initially the velocity is positive, but when it comes back to the same position, it is again negative. Initially it's going this way, it comes back and stops this way. So this is roughly something. Goes is traveling fast and slowing down, decelerating, and then this is a continuous deceleration, constant deceleration motion. This and 3 and 4 are definitely the same, right? This also, velocity versus position, is correct. It goes like this, stops, and then returns. So the only thing that's different is this one. Okay, this one, right, is not the same as 1, 3, and 4. Okay, so why is that? See, this one is showing something. When do you have this? You will never have this if you're continuously moving away, or the distance you've traveled, right? Distance you've traveled is what's happening here, right? It's not the position, right? Position goes and comes back, right? The distance, but your distance you have traveled is always increasing, right? So the main thing is that if you're constantly decelerating, the distance you travel will be parabolic. Okay, it will be in some way. See, if you had this, right? So up to one point, it will also be like this. The distance you travel initially will have to match the position up to the point where it changes, right? Then it will keep increasing. Okay, so notice that. Okay, so it will keep going and then it will go like that. Okay, that is the distance you travel. This is not like that. This is not like that, right? This is going to 0. In fact, because it goes and then going faster and faster the other way, right? So this is not that. If your distance peaks, right, that means the velocity goes to 0. D distance by time, dt, is actually the speed. So at this point, he's saying the speed is 0. furthest point. Actually, it's the other way, right? It goes like this and then it goes like that. That's the main difference. Okay, so the position will be same as the distance up until the point where it stops. Then when it retreats, starts retreating, it will go. Okay, so 2 is not the same. 2 is different. All right. So this is another MCQ dealing with this bodies, masses, etc. Okay. Two masses, 5 and 10 kg, connected by an inextensible string over a frictionless area moving as shown. The coefficient of friction, horizontal surface, that is here, coefficient of friction is 0.15. The minimum weight m that should be put on top of m2 to stop the motion is, okay, m2 and m1 connected by a string, right? The coefficient of friction, right? So now if m2 and m1 are like this, right? T minus um, m plus m2, right? M plus m2 is t minus 0.5 times m plus m2, right? Must equal 0, right? And t equals m1g. So m1g is what? 5 times 10, 50, right? So normally you just take g as 50, g as 10. Okay? So m1g is 50, so t is 50. So 50 equals mu times m plus m2 g, 0.5 times m plus 10 g, right? So 50 divided by 0.15 is what? 0.15, 50 divided by 0.15 is what? 0.15 is 3 times 0.05. 50 divided by 0.05 is what? 1,000. 1,000 by 3. 3333, right? So 3333 equals m plus 10 plus m times g. 3333 equals 10 plus m times g, right? So 3333 divided by 10 is what? 33.33. And then so if you remove that, you will end up with a number, one of these things. So because m2 is right, so you will end up with an answer for that, right? So um, um, so you should end up, I think, with this one 27. You should do the mathematics. No, okay, all right. So then a particle is moving the uniform speed in a circular object of radius r, right? And in a central force inversely proportional to the nth power. Okay? The period of rotation of the particle is t, right? Right. Central force is inversely proportional to the nth power of r. Right. Central force is what? M F equals m is equal to k times r to the power of 1 by n, right? Is inversely proportional k to the nth power of r. So k equal r to the power of minus n, right? So now in the case of uniform circular motion, t square is proportional to r cubed, right? And the inversely proportional to the second power, right? So n is 2, right? So t square is proportional to r cubed. Therefore, you will find that it is something like this or this. So you must find out how to do that. So how do you end up with t square is proportional to r cubed? Okay. So m omega square equals gmm by r square. Okay, so mm will cancel, therefore you have gm by r square. So gm is a constant, so r square, right? So r square is you will end up with r square is proportional to r cubed. T square is proportional to r cubed, right? So now, so you must see how that gets derived, right? M omega square r equals gm by r square. Therefore, the r's come this way, and therefore omega becomes 2 pi by t, right? So now, instead of gm by r square, he is saying gm by r to the power of n. Therefore, now you have r to the power of n plus 1. Okay, so you will have n plus 1 divided by 2, 3. You see, so gmm by r square equals m omega square r, omega equals 2 pi by t. So plug in those things. Gm, the small m's cancel, the big M is a constant, it's part of the proportionality k, right? Therefore, you have this period of rotation of the particle. So then you have this idea of how this all works, right? Gm by r square, right? So k by r to the power of n, right? So that's the movement in this case. So what is the central force? Force is k by r to the power of n. Normally it's inverse square law, right? N is 2. So so what he is saying is it will be n plus 1 by 2. If you don't have square law, then you will have this kind of a equation. So this is some of the ideas around this, right? Now I did want to kind of explain also a little bit about a little bit about kinematics with in 2 dimensions. Let me try to little bit go over projectile motion a little bit, but before that, let me explain this chain rule, right? So so this part I hope you've already learned, right? The a acceleration, the slope of the tangent of the v versus t curve is the acceleration. We already looked at that in that question there, right? So now, if you have a parabola, right? X versus t is a parabola, then acceleration is a positive a. X versus t is a parabola like that. Then you have a negative acceleration. If x versus t is a straight line, then you have zero acceleration. In this case, it is negative velocity. In this case, it is positive velocity, right? So these are all the normal ball dropping cases, right? So and we looked at the more complicated cases. More complicated, they'll put a versus p, a versus, and we saw one problem like that, right? So those problems you must understand. So now we also explained that if you had a v versus t curve, the area under the v versus t curve will give you the displacement, right? Therefore, remember displacement and position. The net magnitude of the area will give you the position, the distance, while the displacement will give you the, if you subtract the negatives as negative and the positives as positive, will give you the displacement, right? So so dv by dt equals a, can also be written as dv by dt, can be written as dv by dx times dx by dt, that, and dx by dt is again v, so v dv by dx. Therefore you have, that's how you derive v square equals u square plus 2as, right? So, and that's how we derive all these equations. V square equals u square plus 2as, vs is equal to ut plus half at square, and then a is equal to v minus u by t. These are the standard equations for something which is in uniform acceleration, constant acceleration questions. Now the constant acceleration can be in the opposite direction to the velocity. What happens then? A is negative. V square will become, what happens if a is equal to g, and the must always get the directions right. The initial velocity is this way, final velocity is that way. V and u are in different directions. All those things you must be very, very careful. Time is the only thing typically that goes forward, but there again you don't know. So learn to apply these problems correctly when you have a is positive, when a is negative, etc., etc., etc. Okay. So now, so this question I always deal with. This is a very beautiful question because this is the kind of question they always trick you with. Okay, the velocity versus displacement graphs. See, when they switch it on you, it's very, very tricky, right? So you must then write the equation. First thing you must do is must write the equation. Okay. So V, so what is this equation? V equals V naught plus, you write this equation as ax plus by plus c, right? X by a plus y by b equals 1, right? V naught by v, v by v naught plus x by x naught equals 1. X by a plus y by b equals 1, right? V by v naught plus x by x naught equals 1, right? So then you remanipulate that, you will get a linear equation in v is a function of x, right? So now you write v as dx by dt, right? Now, if you take another derivative, then the right hand side, you will get a equation of v. You will end up with dx by dt. Take dv by dt is what? A, right? A as a function of v. Okay. So when you take the derivative of the v versus x, on both sides you take the derivative. Left hand side v equals something, right? V is of f of x, right? So then you will have a equals f of v or g of v, right? So now v, you then plug in what you got from the v equals f of x equation into the second a versus x equation. Then you will end up with an a versus x equation. And then you look at which one closely matches this one. Okay, and from what I have heard is you can see that when that this, it's something like the positive equation. It starts with the negative value and then goes the positive velocity. Okay, slope of the equation. Okay, so let's look at that. V equals this one. X by a plus y by b becomes this one, right? V as a negative function of x, right? Now you take the derivative of the left hand side. So then the right hand side, this is a constant, so it drops off, right? So the left hand side will end up like this. Now dx by dt is what? Is itself v, and then you take the v from here and plug it in there. See, he's taking this equation and plugging it into dx by dt, right? Then you end up with this equation. Notice that this is at x equals 0, this is negative, and then it's a positive slope straight line. Okay, the slope of the line is positive. V by x the whole square is positive. Slope is positive. At intercept is negative. This is negative v square, v square by x. Okay, so therefore you will have that kind of a slope. Okay, so why do we teach these problems? So this problem we already dealt with. Why do we teach these problems? So that you are comfortable when you face them in the real exam. Okay, now this second session of the teaching, right, is always aimed as a more hands-on thing. We do less of the theory and more of the problems. So today I've done a significant number of problems. This problem, let's look at this one. Example for uniform circular motion. A hemispherical bowl of radius r is set rotating about its axis of symmetry, which is kept vertical. The bowl is rotating. Small block is kept in the bowl, rotates with the bowl without slipping. If the surface of the bowl is smooth and the angle made by the radius through the block is theta, find the angular speed at which the bowl is rotating. Okay, so now what all is happening, right? The bowl is rotating. There is a normal force. There is g, right? But the net acceleration is what? Is radial. Find the angular speed at which, so that it is small block is kept in the bowl and it stays there without, right? So what can you say? So mg, right? N cos theta equals mg, right? Because it's rotating only this way, right? And n sine theta equals m omega square r, or not r. It's what is the r? The r is a smaller radius. If r is is this length, what is this length? This length is r sine theta. Okay, m omega square r sine theta equals n sine theta. Okay, n sine theta, and therefore n cos theta equals ng, and sine theta is n omega square r, but r is the chord, this chord. Okay, that chord is r sine theta. Okay, so now when you have two equations and two unknowns, you divide the two, and you will end up with an equation for the for omega. Okay, therefore he got square root of g over r cos theta. So draw free body diagrams, understand uniform circular motion, right? So you needed to do both. You need to understand all that's going on in the question. Read questions very carefully. Read it a second time. Always read it a second time. Understand every detail. Notice the word smooth. Notice the word slipping. Notice the word rough. Notice the word mu. Notice when it's moving, when it is not moving. Very critical in understanding um, uh, mechanics. Okay. So with that, I'm going to stop, and I will continue next class. I will take off from where I will discuss this idea of centrifugal force, centrifugal force. The pseudo force, we already discussed pseudo force, D'Alembert, Coriolis, etc. Right? They are all actually the same thing. There is only one force, centripetal force. They are all used to facilitate the understanding in a accelerating frame. Centrifugal force, accelerating frame. Okay. So with that, I'm going to stop today, and I will see you all next week. These classes are intended for the student who wants to understand mechanics better, and then all parts of class 11 better, so that they're adequately prepared for the JEE exam and for the NEET exam. But for both, you must download the app. You must participate in the assessment. Get the app, do the assessment associated with it, and also learn. Go back to the corresponding lecture if you don't get it right. Learn the material well, learn our lectures, learn from IIT PAL lectures, and then of course read H.C. Verma, look at the examples, etc. This is the perfect time for you to get your mechanics right if you're getting ready for a NEET 2023. If you are looking at this lecture and you're going to be taking the exam in May or June or July, it's still good. This is a revision, but you really have to accelerate if you're trying to learn mechanics now and you're going to take the exam in 4 months. You have to accelerate. You have to, get the details right, and or if this is a revision, then that's the best. Okay, revising also, but then it's important to do your own problems. Important to try your own questions. It's important to solve your own problems. Go on the assessment modules. Get familiarized. Get ready and get a few wrong. I say get a few wrong. Learn to learn. Learn to learn. How do you learn to learn? Getting a few wrong. Understanding the right answer. Okay? So happens to all of us. Happens to all of us. Don't worry. Worry doesn't get you much. But learn and get it right. Learn to get it right, and then eventually falls. Okay. So keep studying, and I wish you all the very best of luck.